Hi folks! Last week I told you about problems and solutions with reads optimization in the database. So there I discussed with you things related to splitting the databases, doing this master-slave concept for database reads operation, and as well something about caching. This week, as I promised, we will focus on the optimization of write operations. There are several different solutions for the problem of slow write operations, especially in the cases where your data starts growing. A lot of users are requesting this database for write access and performing a lot of write operations, then your application slows down. First one is the easiest one. So instead of doing write operations with a single insertion, you are inserting things with batches. And what is this batching? It is taking several different operations into one and executing it as one batch operation. So as batch, I mean the group of, for example, insertions or updates or whatever else. And this is something that you can easily apply. Is it possible? Of course it is, but it's nothing really interesting. So another option that you can do is to perform asynchronous operations. This means that whenever your user tries to store some information in a database, you are not storing it immediately, but there is some kind of process that takes this request and behind the hood it stores the data. So user immediately sees that, okay, your data was saved, but in fact, it was not, because this asynchronous operation goes somewhere behind the hood. The drawback of it is, of course, if user wants to read the data or reload the page where he stored some information, it won't be immediately visible. So this might be a bit confusing to your users. The third option is to scale up your SQL server. This is called vertical scaling. You add RAM, you add CPU, modify it, and so on. And then based on this, your server starts to be again quite responsive. The problem with that is that quite fast you will probably face the issue that you cannot scale more up, and this is because the costs will be too expensive, or in general it's not anymore possible. But it is not quite common situation that you will need to handle something else here. If you do, then we come to the point number 4. So when you exhaust all the options that you had and you tried, and I mean here this asynchronous storing, maybe it's not possible at your side, batch operations and scaling up, one of the other solutions is to scale out. And here we are talking about horizontal scaling, which is as well called sharding. What does it mean? Imagine that you have tons of data on your SQL Server database, or Postgres, SQL, or whatever else. And here your database grows and grows and grows. Now with sharding, you are able to take this database and split it to smaller parts, and the smaller parts are called shards. Imagine a situation where you have 1000 customers. Of course, this is a small number. What is 1000? But it is some number. And now to shard it, you are dividing it to two, 500 customers on the right side and 500 customers on the left side. How can you do that? There are multiple ways. First of all, you can use hashing function that will have a key. And then based on this key, you are able to put the data for this amount of customers in the right chart and for this amount of customers in the left chart. So first of all, you can use this hashing function. Second way to do that is to use the range So imagine that your customers are having numbers from 1 to 500 and 500 to 1000, and then new customers come in and they have numbers from 1000 to 1500. So now you take 500 to first shard, 500 to second shard, and 500 to the third shard. This is the second option. Third option is to use it on the regional based settings. So you can imagine that there are customers from Europe, USA, Asia, Africa, Australia, and so on. And then you take these customers and you forward them to one shard. Second customers from the other country or continent to the other shard, and so on. So this is how it can work. This way, you are able to divide your data to a lot of different shards. And of course, these shards might be located on the same database server. So imagine instead of having one huge database on the server, you are having 3 or 4 smaller databases. So because the smaller amount of data are in these databases, each of them, of course, then it is way easier to perform right operation and it will be faster. And at some point you will need, of course, to take the database that is serving some of customers and put it on the other server and so on. So you can scale it infinitely if you want. One very important thing to mention here is that these databases do not share common data unless this data is used like maybe for currencies that you are serving. So the database, each chart which you have will have the same schema, the same tables inside, and the same data from the perspective of the static data. So like the currencies which I mentioned, or some other stuff, maybe regions that you are serving, and so on. So this is some static data that will not change. So you are putting it as well into each of the shard. They are not sharing any shared database, then accessing it for this currency information and so on. But of course, if you have some orders, offers, inquiries, and so on, these are based on the customers that you have in the shard, and this shard will serve only this data that it has in its own database tables. Let me know if you would like to hear more about sharding case, how you can do that from the practical perspective. I am curious if you are doing it as well on a daily basis in your applications. Let me know in comments, like you did the same for the database reads episode, which was released last week. See you guys and enjoy the weekend.